Well, I've gone and bought myself another grinder for the workshop. This is the Meddings SF12. Now, I do already have a couple of bench grinders, as you'd expect in the workshop. I've got an old Challenge one, which I don't think B&Q uses an own brand anymore, and a Titan from Screwfix. That's a big 8-inch actually. That's pretty good. But this came up on eBay. It was cheap enough that I couldn't really say no. Now, if you know what I do, I make scrapers, scraper handles, and scraper inserts, which means grinding a lot of carbide and doing this every day. And carbide grinding dust is pretty nasty, and so I saw this machine. It's got flood coolant and all these nice tables and all that. I thought, well, that would be ideal going forward. But this was sold as a used machine. Now, if you check eBay's listing terms, like the description, so used should be, you might have cosmetic marks or whatever, or might show signs of wear and tear, but is otherwise in good working condition. And so this was sold as used, and that was a slight overstatement. I think for parts or not working would have been a better description. I probably still would have bought it for the price. It was £110 delivered. Big lump of cast iron here and steel. So I'm not unhappy with it. I kind of expected it to need some work, just not as much as we're going to have to put into it. And so to that kind of end, I've actually started a Patreon account. Not because I need help with the general refurb of this machine, but because there is one problem. It's kind of a mundane problem with a lot of interesting answers. So the motor in here is a 440 volt motor. And unlike the other machines in the workshop, which are just out of, we've got the lathe here and the mill over there, which had motors that could be swapped over from star to delta, so from 400 volts to 220, 240 volts, with the change of a few linkages in the motor. These are all 3-phase motors, by the way. So they could be changed over to a lower voltage, which means I could use the VFDs that I do use for those machines are 240 volt VFDs, 240 single phase in, and then 240 3-phase out. So we can't do that with this machine because it's a 2-speed motor. I forget the exact name for the type of motor, but it means that effectively if we want to use it on a lower voltage, that means either sacrificing a lot of power, so there is a way to run it on 240 with a VFD, or rewinding the motor. So there are a whole load of other voltage and phase conversion options available, and I would really like to explore those. So there's, as I mentioned, VFDs. You can take a 440 volt VFD, put 240 volts in there, fit a voltage doubler, or swap around some of the components so you have a voltage doubler circuit, and then you have 3-phase 440 out. That only works with some VFD, so I guess it'd be a matter of trial and error. There are static phase converters, which are just essentially banks of capacitors, which use I guess they kind of use a Steinmetz connection, effectively use a Steinmetz connection. But those then, if you want to change the power of the motor that you've got attached to it, you have to then switch through banks of capacitors to get the right kind of capacitance. So that's a pain. There are rotary phase converters. There are actually multiple types of rotary phase converters, which are probably my favourite option because they give you a pretty close to true 3-phase out, and you can use them with multiple motors. And then there are motor generator sets which give you a true 3-phase out, but I suppose are probably relatively inefficient. Anyway, so I'd like to look through all of those and build all of them, but I can't really justify the cost. So if you want to contribute to that, that's cool. It's not just money, expertise, parts, people's experiences are all really helpful, and that's why I don't know if I've said it in the past, but the most rewarding response to a video isn't likes, which are nice and everything, is actually when people are discussing stuff in the comments. So I'll leave a link to that in the description if you want to, check a few quid at it, great. We can make small videos about the, powering electrics in the workshop, I guess, and yeah, phase conversion, voltage conversion, that kind of stuff. But anyway, we're going to get on with looking at this machine. So starting from the top, we've got this beautiful Yielder lamp, and I posted the photo on Instagram of this, well, the machine. Somebody said, you know, told me what the lamp on top was. I hadn't looked at the plate. I hadn't seen the name of it yet. And I sort of jokingly replied that even if the rest of the machine was scrap, this thing would pay would cover my costs. And it turns out that's true. I went and actually had a look and saw how much these things are worth, and it is true, but it's not for sale. I love stuff like this. Antique kit in general. I mean, this thing's from the 60s, right? And yeah, you know, these sorts of things are really kind of my style, my taste. So over there I've got a mem light which fits on the milling machine, which still needs finishing, needs a last coat of paint, that needs to go back on the mill. So I love that kind of, love this kind of aesthetic. So no, I'm not selling this, but in principle, and I bet a lot of people do, just whip them off the machines and bolt it to a block of concrete and off it goes to eBay, you know. But that's not what we're doing here. We're going to get this thing all cleaned up and restored. Now I don't know what colour this was. I don't know whether that... It's got a light grey on there, and I suspect that's the undercoat showing through, because looking at this side, you won't be able to see this. It's, I'm pretty sure it's the undercoat underneath and it was grey on the top. I don't think it's the same colour as the rest of the machine though. It's something we can get into later. Obviously it's sort of off-white inside. We've got lots and lots of rust on here that all needs cleaning off. These joints, I'm pretty sure are aluminium. They are also solid, so I can't move them. I can move this one, but it takes a bit of force. And obviously I don't want to risk that with pulling the shade here. So yeah, they need work. The whole thing needs stripping down, all the rust stripping off. This doesn't turn. The I guess the swivel there is just stuck solid. And on the base of the lamp we've got this toggle switch here and the power feed cable, both of which are unsealed, so we're going to have to do something about that. Otherwise we're going to end up being splashed with coolant all the time. And that'll be flowing out of the nozzles here and this one here at the back. So these are obviously a symmetrical arrangement. You've got the coolant nozzle which discharges onto the wheel, and that's bolted through a bar, and that allows you to adjust either up and down and in and out, so you can get to your, whatever your required distance is. Unfortunately, most of these little knobs here are frozen solid. I'll say frozen. They're seized. Apart from this one here. That doesn't make a lot of difference because that's seized as well. And this is, as far as I can tell, a bit of copper pipe. So we can always remove that and remake it, but we'll see. The actual hoses, as you can see, are different. You've got two different hoses. So this one's snapped. They're both very brittle. This one actually has snapped. But here's the remains of it on the valve. So there you go. Might as well chuck that away, really. And that brings me on to the valves and the manifold. So we shove our cable to one side. We've got, oh, again, we've got the hose coming into the, well, coming up from the pump. It's also completely solid. So I expect that'll just crack when we come to take it out. That feeds to the manifold from the pump and the sump that's in the base. To these two valves, which, well, they move at least. They seem a little bit on the loose side, but looking at them, it's just it's actually threaded. So there's a little nut on the back side here that we probably just tighten up. Anyway, so our coolant comes down the pipe onto the wheel and back down into the drip tray. I don't know what these wheels are or whether there's any life left in them. Oh, I don't know if you can hear that. If my lav mic's going to pick that up, but that sounds very, very dry. I mean, they're spinning, but it sounds somewhat tortured. So I'll probably be bearing replacements, I think. So we have these guards as well. Again, the same either side. They're not quite the same either side, actually. I think this one's been modified. As you can see, this one here on the other side is wider, and it has a point here that seems to be for maybe a locking screw, something like that, which has been sheared in half on the other one, on the one we're looking at here. So we'll have to sort of have a proper look at that when we take them both off and can compare them properly. Moving down a bit, we've got the table here, and the tables at either end are actually different. They function slightly differently. So obviously they both have tilt, which I can't move again. This is seized. That, oh, there we go, getting a bit of movement. But moving it by hand, I suppose would be sort of undesirable, but if I drop this back down again, yeah, I can't push it back down onto the screw, so obviously this is supposed to have more movement in it. Here we have a big hand wheel which doesn't move, and this I'm fairly sure moves the whole assembly in and out. So that adjusts the angle, that moves it forward, toward or away from the wheel. There is a micrometer collar here. So obviously this is supposed to be fairly precise. This is a tool and cutter grinder. There's a little oil nipple there, which doesn't feel like it's ever seen any oil. Really, bear in mind you've got coolant cascading over everything. So I wonder how much of that washes away all the lubricant, and if you don't keep topping it up, you don't keep attending to it, it's just going to disappear. Here again, we have a micrometer adjustment. So that's your left and right, and this actually. So the way that these are kind of held in place is that you have these springs here. Just a couple of bits of spring steel. So you can see that wobbling. And you have a knob either side. And there's actually two on this side, I think, or at the other end there are two. And that gives you a bit of tension on there so that it doesn't just wobble. And this one is actually fixed to it. So this means you can move, left or right by tiny amounts. 0.075, yeah, sort of minuscule amounts left and right, so you can get a really fine adjustment for your grinding. What you can't quite see here, I'll get the camera around in a minute, there is an angle indicator there for the angle of the table. That's not as precise, I suppose. Maybe I didn't think that was as necessary, I'm not really sure. But the other end, the table at the other end is different in the way that it's arranged. So this is you can precisely adjust this left, right, forward, back, and so on. But we're going to take a look at the other one and you'll see what I mean. In contrast with the table at the other end, this doesn't have the micrometer adjustments. There's no collar on this wheel here. And there's no left, right micrometer adjustment either. You just have these two knobs that constrain the springs. So they limit the movement there. They're all seized, funny enough. It's like half the rest of the stuff on this machine, so most of the rest of the stuff on this machine. There are grease nipples on the trunnion here. And I'm not really sure why. Because they aren't the other end. So are they original? Are they a refit? Well, I guess we'll find out when we take everything apart. This does look like it's either taken a knock or it's cross-threaded. But we'll figure that out later on. So this end also has I suppose this would be a mitre gauge on a table saw, would be what you'd call it. Unfortunately, again, this is absolutely solid. It's welded to the table, this. So it's going to take a bit of WD-40 and a bit of force to take that off. Might get a blowtorch on there. And this looks like it functions much the same way as the mitre gauge on a table saw. You just put your tool up against the face there and run that across the wheel. This machine originally would have come with one of these and another tool for grinding your lathe bits. And it was essentially one of these, but with a couple of rods with springs in them, a little carriage which would go, you could press up and down. And in that you mount your lathe tool, you get it lined up where you want it and the angle you want it, and then you can run it down past the wheel. And that would give you your chip breaker, which there is a data plate for on the back here. And yeah, that would give you your chip breaker or your clearance or whatever you were happening to be grinding on there. It's a really neat little tool. We might have to make one at some point. I'm not going to be doing it in this series of videos, but well, mostly because I don't need it right now. I just need this to grind carbide inserts, but it would be a nice thing to have, wouldn't it? I don't really grind a lot of HSS because it is easier to just grab a carbide insert and replace that once they become worn. So that might prompt me to actually use more HSS lathe tools. we'll see. So moving on, beneath this plate here, which I'm fairly certain isn't original, a lot of pedestal grinders seem to have these, or these big industrial style grinders seem to have plates sticking out that someone's mounted another bench grinder on. But I don't think this is a manufacturer part. I'm pretty sure it's a refit or a modification. So beneath here we've got a plate, nice red plate. This looks like aluminium rather than cast iron, which I'm fairly sure the body of the machine's made of. And it's, I haven't found a match for this colour yet. I might have to go to, just take this up to B&Q and get them to colour match it. It sounds almost plasticky, but it's, I'm fairly certain it's aluminium. Anyway, that has our controls. Behind here is a control box. I've had a look through the other side. We'll get lights down there in a minute. You'll see. But we have a control box which houses the motor switch, so that's our high and low speeds, and the pump control. And these are looking a bit sorry, really. They don't match for starters. There's no selector knob on the pump control. Yeah, it's all going to need quite a lot of TLC, and of course down here we've got the plate for the machine itself. It's got the serial number and RPM, volts, etc. on there. So now we want to get in here and have a look at the sump and the pump, but we've got this plate to remove first. I don't really want to be taking a lot of things apart, but this is in our way. And that's a self-tapper, so I'm wondering if they're all going to be like that, or just, oh God, they're all different. There you go. This is going to need beating back into shape. It's a little bit on the, not really dented, but misshapen side anyway. A few taps with a hammer will take that out. So there we go. And now we can get the lights and the camera in here for a better look. It is a little bit dark in there. So we're going to bring some, I'm going to bring the studio lights in a little bit closer. And there you can see there's our pump, our sump. This is only going to be a fairly small motor on there. It's going to be interesting to see when we take this apart whether that's a 400 volt pump. I have that feeling that it probably won't be. And if it isn't, if that is a lower voltage pump, we can run that off of with a Steinmetz connection. Use a capacitor as your third leg, with your three phase, you live neutral and a cap to the other leg, and that's going to work fine for that works well for small pumps. In fact, I've got a video planned, funny enough, doing a coolant system for the milling machine using the original pump from that, and that is a 240 volt pump, and that runs absolutely perfectly with a cap as a third leg. So yeah, we'll get to that when we start taking this apart, and we'll sort of have a look at it. This is fairly, for what it is, that is quite a big, it's quite a big lump for a coolant sump, isn't it? It's a really quite a thick piece of, I guess, steel or cast iron, whatever that is. It's fairly heavy duty for this application, I think. Perhaps a little bit overkill. Anyway, there we have the return pipe, if we can get in there. Return pipe. Again, it's fairly stiff. I don't know that matters. As long as it's not perished, we might be able to reuse that. That's our feed. That will be replaced regardless of whether I think it's alright or not. So we'll redo all that. Cabling will be redone because that sheathing is looking... I mean, that actually the insulation on the cabling is falling apart there. It's actually disintegrating. So all the wiring here is going to have to be replaced, which is fine. I don't know whether you can see there, we've got a couple of wires hanging down from the control box, which is just here. So to actually chuck a one of the studio lights down on the floor next to the machine to get the light in there. But we have 3 cables running from that control box, and they look like they're joined up and wrapped up in some electrical tape there. So I'm wondering what's going on. Someone's obviously been in here before, because there should be 6 cables running to either a junction box or to the switch. So it looks like this may have been wired as a single speed. I don't know. We'll find out once we get into that box and see what's actually in there and get the motor off and see if any of the wiring has actually been tampered with, because that could be a bigger problem. Quite why there's a connector block there, I have no idea. And here I think is, I wonder what's going on there. Got a big cooler cable there. Oh, and that goes off to the pump. Now that's a lot of cable running to a pump, isn't it? Does anyone else think that something isn't quite right here? Well, what you can't see from that side is the cable running to the isolator or the on-off switch on the outside. So we swing the camera around and you'll be able to see this lovely MEM switch box here. So this is a isolator, quite a heavy duty 3-phase isolator. You see it's got a 5 horsepower rating there. Is that 500 volts? There we go, at 20 amps. So we turn this off. I love the style of these things. So I do. This is massively overkill for this machine. I mean, 20 amps. This doesn't even get close to that. Bear in mind, this is the motor on here is less than the horsepower. Even with that little pump, it's not going to get close to like 1.5 horse. So this is overkill. And we've still got the fuses. Got a little nice switch here. See, someone's just cut all these cables. What a bit of butchery there. And I think that's putty, mate. I hope that's putty. I mean, oh, that looks like is that just Play-Doh? God knows. I don't know if you can see from there. That's multicoloured in there. God knows what's going on there. But so someone's tried to stop up the cable entries. Anyway, we've got the fuses here. I can't actually see. I'll have to hold this up to the light. Yeah, 20 amp, 500 volt. This is maximum wire. I can't actually see what it says. 25 25. I don't know. Anyway, that's our yeah, the old rewirable fuses. I do have a few of these knocking about, but I haven't used them for a long time. The last time I actually had to rewire one of these was probably 15 years ago. So will we use that? Won't we use that? I think that depends on the method that we use to power the machine. If we go with something like a rotary phase converter, then yeah, we'll wire it via this. I mean, I suppose if we're chucking 3-phase in, we could just wire it through here, regardless of how we're doing it. So let's put the correct fuse wire in there. I suppose it saves buying another set of breakers, and then again, I'm going to put an RCD on there or whatever anyway. So I don't know. Maybe we'll keep it there. Maybe we'll salvage it and use it in a different project. Now that we've had a look over the machine, we've got a rough idea of how much work it's going to take to bring this back to running order. Now the only showstopper I can imagine is going to be if this motor is knackered. If that's shot, it's going to mean a motor rewind. That's more time, more expense. If it needs that, it needs it. Hopefully it won't. But testing that is going to be a priority in the next video. Other than that, minor inconveniences are getting hold of the paint. So this is a metallic blue. Rust-Oleum do a matching colour. I've got the colour code somewhere, but they don't seem to sell it in the UK. So either they're selling it under a different name, but the colour is a different shade, or they just don't sell it here. I know I can get it from Europe, but I'm paying through the nose. So I'd rather just see if I can get it in the UK, and I can get it in short order as well, rather than waiting for it to come through customs. Likewise, the red paint, I don't know if this is red, maybe sort of plum, I'm not really sure what shade you'd call that. I'm probably gonna have to get that colour matched. I was gonna just go up to BMQ and get the Valspar paint and just get them to colour match it up there. But having read the spec sheet for their metal paint, it would have been fine on the pedestal because it's not exposed to coolant. But it's a permeable paint, so I think that's probably a non-starter for the guards. So let's see if I can match that somewhere. Even if I can get a close match, I would be happy with that. So yeah, those are really the only sort of inconvenient bits. Everything else is just replacing parts or freeing stuff up where it's seized. I'm really looking forward to seeing this machine put back to work, especially after using the bench grinders that I've got for years. There's nothing wrong with those, you know, but this will allow partly a greater degree of precision, but also it will keep the dust down. So now that we've got coolant there, it won't be kicking carbide dust up. I'll still be wearing a mask, but it's better from a health and safety point of view, I suppose. Anyway, in the next video, what we're going to be doing is, firstly, as I said, testing the motor. That's the priority. Then we'll pull this entire assembly off, because these tables are mounted to this headstock here. We'll pull all this off, get it on a bench, and start taking things apart, laying them out, and seeing where we are with what needs to be replaced, what needs to be repaired, you know, stripped, sanded, repainted. That'll be the next video. So yeah, I will see you in the next one, and I would say I hope this has been helpful, but I don't think there's a lot of these machines out there, so if this is helpful for you, great. Actually, if you've got one of these, leave a comment, get in touch. I'd be interested, especially if you have one that is in working order, that's in original condition. I'd be interested to know if this is the same colour on the inside of the drip tray, any other details you've got. Otherwise, I hope you've at least enjoyed the video, and I hope you'll enjoy the next one, because that's when we're really going to get into the meat of things and start getting it torn down.